researchers. We've been doing that since 2006. So that's a service that those NSF-funded researchers get for free. So we sort of help manage their data, make sure that it's properly described with good quality metadata, that it's citable and publishable for the researchers if they choose, and then ultimately make sure that it's archived at what used to be called the National Oceanographic Data Center, now called NCEI, a larger effort for US-funded data. Okay, and so BCO-DMO has been really a data management office that's really driven by the community needs, and so there's a lot of ground-up technology adoption based on what the researchers want, and so out of that came a data catalog on the web of just their metadata, and that's this www.bcodmo.org site. And so there was a need to provide a search across all of our holdings, and by holdings I'm talking about just sort of the high-level concepts of metadata. So, you know, the name of the data set, what instrument was used, or the name of the instrument, what parameters were collected, who did the collecting, what awards did they receive from NSF or other funding bodies to do this work, what did they call their projects. So all these sort of high-level metadata concepts. Those are in Drupal, and we needed a way to search across just not those individual categories, but across that entire collection. And so, I mean, just as an example, we most recently had a question, hey, can you point me to all the microbial data that is, you know, exists below the 45-degree latitude or something like that. And so putting our content into Elasticsearch was one way for us to at least begin to answer questions like that. And so we reached out to David Bassendine at Bluedot Lab to help us build this effort for Drupal 7. And so I'll turn it over to David.
Thanks, Adam. It's great to be here. Can everyone see my screen? I'm sharing.
But you can see your screen.
Okay, that's great. So yeah, thanks, Adam. It's great to be here. And you know, if you have any questions while I'm running through this, then feel free to chip in or put your questions in the chat, and I'll pick them up at the end. We just wanted to run through how we put together this integration between Drupal and Elasticsearch for the BCO-DMO metadata catalog. So I'll run through some of the advantages of Elasticsearch and how it looks to interact with it, and how we put together the architecture and some of the sticking points and problems we ran into, and how we solve those. So yeah, as Adam said, the BCO-DMO metadata catalog is a pretty large catalog, certainly in Drupal terms. There are almost 13,000 documents across 12 data types, so covering data sets and people to funding and projects, as well as many others. So all that metadata is input and curated by a team of data managers at BCO-DMO. And we set out to index it using the search API for Drupal 7 connected into Elasticsearch. So yeah, as Adam said, the main goals for this were really to set up a keyword search across all 12 data types and be able to filter those by the type. So that was quite straightforward, but we really wanted to leverage Elasticsearch so that we could push all the metadata that was stored in Drupal and another search index that would open up opportunities to reuse that metadata at greater scale and for different applications. So one of those was FacetView, which is a JavaScript frontend to ElasticSearch that Adam demoed at the summer meeting. And actually, this presentation follows on from a number of other ElasticSearch case studies at the summer meeting, so go check those out. So just to show you what we built, we ended up with as at the end of this project. So here's the you can search. You can search by any keyword. Returning documents by searching by relevance through the full text fields in these different metadata documents. And you can filter this down by one or more types if you wanted to. So it's quite a straightforward search, but it fulfills a core need at BCO-DMO. So I wanted to run through ElasticSearch and why use it. I mean, typically to do search on Drupal, Apache Solr has been used. So why does ElasticSearch improve on Solr, and why do we pick it in this case? Well, one big advantage is, I mean, at its core, it integrates a number of different capabilities and provides access at scale. So it acts as a kind of document store, like a NoSQL database, like MongoDB. And it allows you to do keyword search against fromElasticSearch and assess its relevance. Do analytics on
Hey, David, this is Tamir from CDWG. I wanted to ask you, there's a bunch of instance numbers for all 5 of those kits. I wanted to see if there's one specific one that you'd like to be removed, so we can go ahead and go forward with this and get this taken care of for you.
Sorry, I think someone's not on mute, or...
Yeah, please mute your phone if you're not speaking. And David, people want you to speak a little louder if you can.
Okay, sure. Yeah, so it acts as a document store like MongoDB. So you can interact with it via a REST API over a standard web interface, and it will return the documents in JSON. You can run keyword searches against all the full text fields in your documents and return results based on relevancy. You can take buckets or subsets of your documents and run statistics against them within the search engine, and you can do location-based search. And a key feature is this: you can add what are called, so you can add an Elasticsearch node, which is like an Elasticsearch server, and scale this out horizontally. So you can really, as your demands increase, you can scale up your capacity very, very easily. Also, you'll find that the response time and latency with Elasticsearch is a lot more stable than Solr. So with Solr is pretty fast, but the response times break down when there's indexing going on, or if you're trying to query large numbers of documents. So Elasticsearch response times are a lot more consistent and faster. So that's what So that's what they call, that's kind of marketing buzzword, real time. But it really means there's low latency consistently. So results can be queried as soon as they're indexed. Also, you can build out a lot of applications on top of Elasticsearch, such as there's the company behind Elasticsearch provides a tool called Kibana, so you can create visualization dashboards. I mentioned Facet View, and it's also used a lot for collecting log data, which can then be analyzed and visualized in what's called the ELK stack. So I just wanted to show you how it looks kind of in practice if you set up an Elasticsearch server locally. So I'll run some queries in the browser against the BCO-DMO database. So here you can see all you have to do is, once you've installed it on your local machine, you can just query it on port 9200, and then it has a pretty straightforward like REST style interface to run queries. So this one shows the indexes that I have set up. So in this case, the main index for Hui is this one, Hui BCO-DMO Live. So these numbers refer to the number of shards and replicas. So a shard is a kind of horizontal split of the index, so you can spread it across different Elasticsearch servers for horizontal scaling. And replicas provide backups in case, and fallbacks in case one of the indexes go down. And then you can see it has 11,866 records. This refers to the index size as well. So you can retrieve a particular document very easily. You just define the type and then the document ID. And so you can see it has a number of metadata fields, one to Elasticsearch itself. So it defines what index it's in, the type, ID number, versioning. And then the source is actually the JSON document itself. So what you'll find is a key advantage of Elasticsearch is that it has very flexible automatic schema. So you don't need to define any schema, you just give it a JSON document that will build the schema itself. So it will build a schema for each type of document that it indexes. So these are the fields and values for these dataset type documents. So if you want to run a search, you can use this _search, and then you put your query as the Q parameter. So you can see here we search for chlorophyll, got 438 hits. And then it will provide the results as an array of JSON documents, giving the relevancy score, and the type, and the document fields as we had before. So the default is things like 10, but you can configure it like yeah, and then you can also do searches against particular dataset types, and this just really scrapes the surface. I mean, you can define what's called a bucket of documents, and then run analytics queries on those, or location-based queries. Yeah, I recommend looking at the elastic.co site, and that has really great documentation. Anybody had any questions about Elasticsearch itself?
I mean, how easy is the integration in Drupal? How's that?
Okay, yeah, I'll come on to that.
Okay.
Yep. All right, I'll skip on. So this is the stack that we used for the integration with Drupal. So we pretty much so you install the ElasticSearch server, or you run it on a different server. Then what you need is the PHP library. So in this case, we used Elastica. And there's an alternative one, the official. This one was written by the community's open source project. And there's another PHP library that's the official version, written by Elastic themselves. And I'll run through that stack later. So then you're using Search API, which is a framework for searching in Drupal that's very flexible. That's kind of the best practice for searching Drupal right now. Then Search API Elasticsearch is a way that integrates Elasticsearch into Search API. So it allows Search API to talk to Elasticsearch. And then because we were bridging across multiple content types, then we used Search API Multi to search across those different indexes. And I'll run through why we chose that approach in a couple of slides. So pretty much you have Elasticsearch, then PHP talking to Elasticsearch with Elastica, then Search API and another module to bridge between Search API and Elastica. So how we set this up kind of was driven by the need to index the metadata documents of different types cleanly in Elasticsearch, as well as just return search results from Drupal. So what we found was that in the default setup in Drupal, when you indexed multiple different content types, it would not map those to individual data types in Elasticsearch. So that posed a problem because you'd find that every document had all the fields from every content type, and it didn't define the data types in Elasticsearch properly. So this is how, if you set Search API up by default, this is how things turn out. So you have a couple of different content types or bundles. Usually you would set up a single index in Search API. And then in Search API, you also have a server which is the way that Search API talks to a particular backend indexing system. So as is shown here, you'll find that each index which contained multiple content types, or was indexing multiple content types, would create documents of all the same type in Elasticsearch, and that single type would have all the fields from all the content types. So in the case where a content type didn't have that field, it would be in the schema, but it would just be marked null. So this didn't offer a very good way for returning search results from Drupal. It works fine. So for that application, it's good. But for reusing the data within Elasticsearch and for other applications that build on Elasticsearch, it doesn't work well because then you wouldn't be able to segment queries by that content type. So this is the architecture that we ended up with. So essentially, we still had a search API server that talked to Elasticsearch, but we would have an index for each content type, and then that content type was then mapped to a data type in Elasticsearch. And each data type would just have the proper schema of the fields that were contained within it, rather than all the fields. So just skipping back, we decided on just to run one Elasticsearch index. For performance reasons, it's quicker to query it than a single Elasticsearch index. So we mapped a content type to a search API index, and that mapped to an Elasticsearch data type, giving each one a unique schema. And it also had the benefit that in Search API, a lot of the configuration, which I'll show in a minute, is set per index. So if you really want to tweak indexing, say, of data sets versus people, say you want to index different fields, or you want to put different filters of what is and isn't indexed, then it's a lot easier to configure that per index and per content type. And also, when you want to re-index content that's in Drupal, then you only have to do it one content type at a time, rather than having a huge monolithic index with 12,000 documents in it. So let me just show you that, how it's set up in Drupal. You pretty much install your Search API module, your Search API ElasticSearch module, and have an ElasticSearch server running on your local machine. So on Linux systems or Mac, you can do that by just installing a package, and it's very easy. So once you have those set up, then when you come to Search API, you'll come and you'll add a server. So this ElasticSearch server is where the connection details to your locally running ElasticSearch is set up. So under node 1, so you'll say, okay, running on my local host, on port 9200. That's pretty much it. So there's nothing else to do. So then you'll add your indexes that tie into the server. So an example of that is this dataset index. So a recent addition to a Search API was the ability to kind of filter what you index by content type. That came in a couple of versions ago. So instead of having to run through all of the nodes as you're indexing content from Drupal into ElasticSearch, you can just say, sort of restrict it to this content type. That's what we're using here under data source options. So we've restricted this to the dataset bundle, and bundle is really just an equivalent for content type, in case you want it. So you're saying, yeah, this is using Elasticsearch server. We're just indexing datasets. How many shards and replicas? That's Elasticsearch settings. And then you come to fields and you say, okay, so which fields do I want to index? So which fields do you want to index? So you literally just check the fields to index, and you select how they're indexed in Elasticsearch. So if we want to do, what should we do? So if we were doing last name, for example, so we turn that on, and then we have the choice of how the content in that field is represented and analyzed or indexed in Elasticsearch, and that ties into how that it's analyzed and how it can be queried in Elasticsearch. So if you select a full text, so this is a text field, then that text can be broken down into words and assessed against a keyword search for relevancy. Or it could be a string, in which case it's just going to look for a match against the whole text string. So it'll either match the string or not match it. So if you have a full text, you can also say, well, yeah, matches in this field are really more relevant than other fields. So that's the boost setting. So if it has a higher boost value, it will prioritize results that match in that field. So yeah, you set up the fields that you want to index, and then you can set filters. So this really restricts which nodes are indexed. So here we're saying we're not going to include anything that's unpublished. And there are other filters you can also add. One good option here is you can actually aggregate fields. So you can say two text fields that you want to index together in Elasticsearch and combine. You could do that there. And then in analysis, you can define which analyzer Elasticsearch will use. So this is really talking about when a keyword query is entered and it's searching against a number of full text fields. How does it break the full text fields that it searches against down? How does it run the query? But usually the default is fine. So that covers the indexing side. And then when it came to querying to set up the search page for BCO-DMO, then we used a view which was running off the search API multi module. So I'll just show you the slide for that. So in our case, because we needed to separate the content into being indexed by different indexes, so that we had a good data structure in Elasticsearch. So then we had to search across multiple indexes. So by default, Search API doesn't really do that well in Drupal 7. So there is this module, Search API Multi, that allows you to do that, but it introduces quite a few limitations. So, for example, facets aren't supported. A lot of extension modules to Search API aren't supported. But in our use case, then this worked quite well because we were searching across multiple types, and there's limited need for facets when you're searching across multiple types and they all have different fields. Facets are based on a consistent field across all your documents. So this worked pretty well. I'll show you how it's set up. It's pretty much a standard view with. So the one drawback of this is you need to set a field for each. So this is the fields that are displayed in the search results. So you have to return set it up with a title field for every index that you have. Other than that, it's a pretty standard view. Now, one key problem with this module is that it, by default, just searches every index. So you may notice that Search API we're also, BCO-DMO also using it to index documents into the Drupal store. So when we started to use this, it was trying to index everything or search against all of these other indexes as well. So we had a patch to solve that problem. Okay. So yeah, this is again talking about the issue with Search API Multi. So we altered the query so that it would exclude or only include Elasticsearch server indexes. And this problem with Search API is limitation to a single index. It's going to be pretty much solved in Drupal 8. It's going to be a lot more flexible. So hopefully this architectural blocker will go away. And we also had to kind of modify Search API Elasticsearch. The problem there was that by default, every index in Search API would create a new index in Elasticsearch, but we wanted them all in the same Elasticsearch index. So we wrote a patch to help with that too. So did anyone have any questions about like how this was set up in Drupal? Just, yeah, shoot. That's fine. Any architecture questions?
David, are you looking at the chat? There's a question in the chat about the current version of Elasticsearch 2.4.1. Is there any difficulty in implementing this with the current version that you know of?
Yeah, okay, that's a good question. Thanks. So going back to the stack, So yeah, this Drupal 7 stack is pretty much stuck to ElasticSearch 1. And the one version, the one branches of the PHP libraries. I think when you're looking to ElasticSearch 2, then you should look to Drupal 8. So I have a slide on this upcoming Drupal 8 stack. So yeah, you can use the 2x branch of ElasticSearch with Drupal 8. You would use ElasticSearch PHP, the 2 branch of that. And there's an alternative Drupal module that connects Search API and ElasticSearch, and you use the 2x branch of that. So Search API itself is in beta for Drupal 8, so there's not any major bugs. It's supposedly usable, but not necessarily production ready. But I think that's pretty much will be good to use now or soon, or it's definitely good to test. So the Elasticsearch connector module is in dev for Drupal 8, so we're still waiting for a stable release of that. But that seems to have some good momentum behind it, so I would imagine that that's going to be ready pretty soon. At least keep an eye on it. So coming back to Drupal 7, there's 2 different stacks you can use, and probably this alternative stack is more kind of forwards compatible if you're then looking to Drupal 8. It's still stuck to ElasticSearch 1, but it uses the official ElasticSearch PHP library, which the community-written one is been around longer, and it probably has better community support, but I think the official library has more funding and a lot better documentation, so I think that's come through, or going to come through, as the main PHP library. And there's a different Drupal module, as I mentioned, for Drupal 8 called ElasticSearch Connector that will that uses the official PHP library, and it also has some other capabilities, such as you can push your Drupal logs into ElasticSearch with it, and it'll also collect your kind of your web access statistics and push that into Elasticsearch as well. So I think that's a worthwhile stack to explore for Drupal 7. At the time, they were more evenly balanced, and it wasn't clear which one was going to come through for Drupal 8, but it seems like ElasticSearch Connector has more momentum behind it right now. Okay, that's it. Any more questions? Or ideas about how you might use this? Yeah, go ahead.
So is ElasticSearch used in different CMSs? Is there ElasticSearch for WordPress and other things? I guess I don't know much about it. How widespread is it used? I'm just thinking about the longevity of this as a technology.
It seems, well, I'm not sure about WordPress. It seems to have pretty good backing behind the company that's behind it, and a lot of different integrations with other technologies that are building up a kind of ecosystem around it. So I'd be pretty confident that it'll be here for a long time. I mean, it really solves the problem of scale that the Solar had, and yeah, I see it being around for a long time. I'm not sure how widely used it will be in CMSs. I think this is a kind of, it's really focused on medium-sized or big data. I think that's where it shines. I guess in this case, Drupal's being used to collect kind of large catalogs of metadata documents, and that's probably not the typical use case for Drupal, or other CMSs. So it probably wouldn't, its advantages wouldn't be too apparent versus Solar for most kind of CMS type applications. But I mean, it's still quicker and more flexible than Solar, so there's no reason not to use it. Adam, did you want to chip in with anything that I missed?
Hey guys.
How have you found it since the project finished, and where do you see this going?
Yeah, it's been great for us so far. So this was the first step in a longer-term vision for us in using ElasticSearch. So David, at the beginning of the talk, mentioned this library called FacetView, which is a tool. It's a client-side JavaScript library that interacts with ElasticSearch's faceted capabilities. And so we've just done some quick use cases and proof of concepts there that we could take all of our BCO-DMO content and render those facets with this FacetView library to build out a faceted search across all of these indexes or the document types in this one index. And so the next step for us is to take the work that David's already done and flesh out more content in the documents that we're storing in the index, and then put on top of that this FacetView library to have faceted search within our Drupal site. So that would be the next step, and then I think the final step would be to add in some of our semantic content so that we're not just talking about the names and labels of things, but their globally unique identifiers on the web, so that other folks can reference these items in our Elasticsearch documents and see how they connect within the greater ecosystem of data in the geosciences.
Cool. So yeah, there's a number of tools that kind of plug into the Elasticsearch index, that are, some of which are written by Elastic, the company behind it. Other ones are like free and open source, but like from what you just said, Adam, there's a graph plugin that would help you explore connections between, explore the graph of your metadata documents. So I know it's a very highly linked collection of documents, right?
Sorry, I was on mute there. Yeah, that's right. And I think some of the other tools that are built around Elasticsearch are great. Like I think it has this explain API where if you don't understand why a document's coming back in a search, you can point it at this explain API and it'll tell you exactly why and how a document's coming back. So there's just a lot of really nice tooling built around this technology, which I don't know if this got mentioned or not, but in essence, it's built on the same backbone as Solar, right? It's just Apache Lucene, but with a REST API built around it. So that's really nice.
Yeah, it is also open source, and as you say, based on Lucene, just like Solid. So. So yeah, did anyone else have any questions? Well,
Yeah, I have a question. Can you hear me?
Yeah, go ahead.
So there's a desire to build out kind of an autonomous relationship builder between content. Have you used the Elastic API to kind of bridge gaps in your different varieties of content?
No, I think that would be a really interesting application for this. This was kind of a first step of just getting this content indexed properly into ElasticSearch. And I mean, did you have an example in mind?
No, it's one thing that is requested that I attempt to produce, and I've been exploring or considering ElasticSearch not only for our search, but also to build kind of that autonomous relationships between similar content.
So when you say autonomous relationships, you mean
Like without a user having to go in
autonomous.
and without a content editor having to manually create relationships between content.
So it might
So
be
for
like
example,
shared fields.
the one content would have some keywords in it that basically would query related content.
So if you visit that piece of content, it might show you related pieces of content based on
The keywords that are in the article, for example.
Yeah, I'm sure that could be done. I'm not aware of any module for that. Yeah, that seems the use case that Elasticsearch could help with.
One of the nice things about Elasticsearch having a REST API is that you can call those REST endpoints to build indices, index documents, which is really nice because you can use machines to automate a lot of that process. And so we've done this for the individual data sets. So as one of our other proof of concept, we tried out, hey, if we know where a tabular data set is, can we throw at Elasticsearch just the column names that will be found in that data set and have it build out automatically this mapping based on the data that it sees for those columns, and that worked. So that was really exciting that we could, at a very generic level, obviously, build out an index over data without having to have a human set that up. We could just write code that would look for tabular data sets and build these searchable indices for those. So that was, I don't know, that doesn't really relate to your use case, but I think the automation part, I think would relate to that.
Yeah, thank you.
Yeah, tapping into that, I think another big step forward is just the schemas for these documents. Elasticsearch will just set up when it's indexing them, rather than you having to define any schema. With Solar, you had to define schemas manually. This will just take a JSON document and just handle it.
So would this defeat the purpose? But what if you were to do kind of a native server rather than connecting to an external one? Do you think that there would be some major drawbacks there?
Do you mean running Elasticsearch on the same server as your web server?
Yes.
You can do that. It would all depend on the amount of resources that your web server had, I would suppose. So probably it would be, I think BCO-DMO, are you running it on a separate server, Adam? On the same?
I think it is running on the same web server in our case. And I think we did that because we didn't have any other place to put it, and we thought, well, let's just try this out and see if it performs well. And it's been great for us. So, you know, our site isn't terribly high traffic. I think we get about 1,000 to 2,000 unique visitors a month. And so that web server is handling all that traffic in Drupal, doing the indexing for Elasticsearch, and then obviously exposing that content. So, yeah, I think it's certainly possible.
Yeah, I think it's possible at the kind of low end or normal end. You know, once you were trying to scale up the queries, then you probably want to move it to a separate server, or there are a number of different hosted Elasticsearch services. There's one called Elastic itself, Run One, and there's another one called Qbox, I think, and some others. So. Any other questions?
Are you going to make your slides available?
Sure. I'll send out an email to the mailing list with the link to the slides, and we'll be posting this on YouTube as well.
Thanks, David.
Yes, thank you.
Okay.